Right, section 23.2, page 346. Volumes and surface areas of pyramids and cones and spheres. Now, all the formulae we'll be using in this subsection 23.2 will be given to you on the front page. Just turn it over of Unit 3. All the formulae we're given to you there. You're supposed to know things like A equals pi r squared, C equals 2 pi r. You're supposed to know Pythagoras, and Pythagoras does figure in this section. You'll see in a minute. But the other grade A formulae, you'll get used to them as you do them, and so you get to learn them actually. So, but should you fail to learn them, and they'll be given to you anyway. So here we go. Question 1A, starter grade A question. Find the volume of a sphere of radius 5 centimeters. So there we go, a sphere, and that's like 3D type thing, isn't it? And the radius is sort of from there to there, and we're told that's 5. Now you may recall the volume is 4/3, in other words 4 divided by 3 times pi times the radius cubed. Please note a length cubed, therefore it's a volume, isn't it? Let's just substitute what we know. So we're going to go 4 divided by 3 on our calculator times pi, take it to be 3.14, multiplied by the radius cubed, which is 5 cubed. Punch that into your machine like I did, and you will get 523.3 recurring centimeters cubed. And that's a lovely, lovely question. Part B, that was A. Do B across here, I think. A hemisphere with radius 10 centimeters. So it's the volume of a hemisphere. So what we've got there, we've got ourselves one of these. It's like a half an orange cut in half, and there you go. Now if it's the volume of a sphere, then here we have a volume of a hemisphere, and the radius is 10. So from there to there, we've got a radius of 10, whereas before it's just a radius of 5. Alright. So let's just work out a full volume. Again, quote the formula. There's no marks for writing this down, by the way, because they're given to you in an exam booklet anyway. But for the purpose of teaching and for your own clarity substitution, let's write it down. So 4 divided by 3 times pi times radius cubed, which is 10 cubed. We'll get our answer, and then divide by 2. Well, I didn't actually get an answer, did I? What I did was I actually did 4 divided by 6 times pi r cubed. But let's just get an answer now, and see if you're happy. Right, so 4 divided 3 times 3.14 times 1,000, because that's what 10 cubed is, isn't it? Bam. So I've got 4,186.6 recurring, and if it's in centimeters, the volume's in centimeters cubed. Therefore, hemisphere has volume of, be that 4186.6 recurring all over 2, and I'll just give my answer now from my bit of paper. 2093.3 recurring centimeters cubed. We'll do question C up here. What have we got now? I've got to work out the volume of a pyramid of height 12 centimeters and a hexagonal base of area 36. Well, it's quite hard drawing it, but it doesn't matter. Look, 1, 2, 3, 4, 5, 6. This is me trying to draw a slanty hexagonal base. There's a little spot there. If I use this facility, then maybe I can draw down to each vertex and it'll look half decent. Oops, I missed it completely. Never mind. Do you see what I'm trying to do? Go from the common point to each vertex. Yeah, that's not bad. Allow me that one, please. So that's that. Now, anyway, fortunately, the base area has been given to us. So let me just write down here: area equals 36 centimeter squares. And I'm told that the vertical height from top straight to the bottom, and I'll draw this in a different colour, from there straight to the middle, so it'll be like a vertical drop straight down to the centre of the base there. I'm told that's got a height of 12 centimetres. So if I put here h equals 12 centimetres, right? And try and label that to the red bit there. Okay. So what have I got? The volume of any of these things, of any pyramid, is going to be 1/3 of the base area multiplied by the height. Now, thankfully, I didn't have to work out the area of the hexagonal base. It would have been a regular hexagonal base, I'm sure, otherwise it couldn't be done. So I'm told it's 36, so let's just substitute. Equals 1/3 of 36 multiplied by the vertical height of 12. Well, a third of 36 is 12, that's going to be 12 times 12, isn't it? And then 12 12s are 144, because everybody knows the 12 times table. And centimetres cubed. Well, not everyone knows the 12 times table. I mean, everyone knows that 12 12 is 144. You all know that. Okay, that's question 1 done. We'll do question 2 and probably just stop for a bit. Right. Lovely. It's a one-liner, still into grade A. It says, this is question 2, find the total surface area of a square base pyramid with all the edges of 5 centimetres long. So I'm supposed to work out the whole surface area of a square base pyramid, and I've got just one number. Well, okay, let me just try and draw it then. Try and draw it in red so it looks half decent. Does that look square enough to you? Okay, let's put the vertex here somewhere. There. There. How's it looking? Or getting in the way of the seaside. Right, that's not bad. It says here, all the sides are 5 centimetres long, so that's going to be 5 centimetres. Going back in towards the St John's Church there, that's 5 centimetres, and each of these edges are also 5 centimetres. Alright, so that's 5 centimetres as well. Now look, I've got a triangle here. Watch this. I've got one like that. I've got one over here. Alright. I've got one at the back. And I've got this little slanty one here we can hardly see because of the way I've drawn it. And of course I've got a spare base. Now, let's do the difficult bit first. If we imagine this front triangle here, then just pull it out and just draw it separately. So imagine I've got this front triangle. There it is, so it's this one here. I'm trying to pull out and draw it next door there. So let's just go back to black then. So I know that's 5 centimetres. I know that's 5 centimetres. I know that's 5 centimetres. Now, how do we do the area of a triangle? Half base times the height. Okay, well, let's just draw a perpendicular straight down there. So from there to there, I need to work out the height, don't I, in order to work out the area. So if I put down here an h equals, I don't know, we can clearly use Pythagoras to work out the height. Now, if this is a perpendicular bisector splitting the base of this triangle in half, then obviously half the base is going to be 2.5 centimetres. There's your right angle. There's your hypotenuse of 5 centimetres. So Pythagoras is ready to go. So if you recall, the height is going to be the hypotenuse squared, take away the other smaller side squared, and then you press the square root button across all of it. Alright? So in one step we can do that, can't we? And I've worked that out to be a 4.33 centimetres. So the height there is 4.33 centimetres. Therefore I can now go ahead and work out the area of this triangle. So area of triangle, let's work over here now, of a triangle is going to be half base times height, which is a half times 5 times the height of 4.33 rather. And let's just get an answer for that one, just a single one, shall we? And I made that before. I've got it here, 10.825 centimetres squares. Now, how about the area of the base? Well, the area of the base is dead easy. That's going to be 5 times 5, which is 25 centimetres squares. Right, just that's the base all filled in there. And now the total area, in other words, the total surface area of the square base pyramid, is going to be 25 centimetres squares from the base plus 4 lots of this 10.825, because remember each triangle has a surface area, or just an area of 10.825 centimetres squares. And I've got 4 of them going all the way around here, 1, 2, 3, 4, and I've got the square base. So adding up all these bits and pieces, 4 of those and 1 of those bases, I've got 68.3 centimetres squares. I'm going to stop there. Very straightforward grade A starter questions, so I'll leave it like that. I might contemplate changing colour to yellow again, see how well it stands out. Oh, that's quite nice and bright, isn't it? Yeah, I think I'll go for that. These are the key numbers we calculated from before. there you go. I'll probably use yellow and stuff like that. Right, that's video number 1 done. It's probably about 4 of these just on this section alone, because there's some very complicated questions coming up. I know, because I've done them. Anyway, catch you later, and we'll talk again.